Hello friends,
Hello
so
friends.
here in this video of theory of computation, we are going to learn about the topic conversion of DFA to regular expression and vice versa. First, we are dealing with DFA to RE conversion. As you all know, DFA stands for deterministic finite automata and RE stands for regular expression.
This is DFA and this is RE.
So first we have to learn about Arden's theorem. On the basis of this Arden's theorem, we will able to convert DFA to RE. Now, what is Arden's theorem? Arden's theorem says that let us consider P and Q are the two regular expressions. If P does not contain a null string or epsilon, then R is equals to QP form as a solution R is equals to QP star. This is the statement of Arden's theorem. Now, applying the statements on an example. Example. Construct a regular expression corresponding to the automata given below. Now, in this example, we are given a DFA. We must obtain equation. Before applying Arden's theorem, we must obtain equation for all the states. In DFA, in this DFA, there are three states, Q1, Q2 and Q3. Let us obtain equation for Q1. For obtaining equation, we must focus on incoming edges of states. So for Q1, there is only one incoming edge. So equation of Q1 is Q1 is equals to Q1 0 plus epsilon. We are written Q1 0 because 0 is the incoming edge on Q1 state. For Q2, there will be two incoming edges. So in equation of Q2, Q2 is equals to Q1 1 plus Q2 0. For equation of Q3, there are three incoming edges. So the equation is Q3 is equals to Q2 1 plus Q3 0 plus Q3 1. So here are the equations given below. Now, I Arden's theorems on this equation. As I said earlier, equation of R plus QP form are converted into R is equals to QP star form. So Q1 is the equation which is R is equals to QP form, where R is Q1, Q is epsilon, and R and P are Q1 and 0. So apply this, Q1 becomes Q1 is equals to epsilon 0 star. We can remove as epsilon as it is a null string. So apply this procedure on Q2 state, we obtain an expression Q2 is equals to 0 star 1 0 star. This is the final regular expression. We don't have to apply Arden's theorem on Q3 state, as Q2 is the only final state which includes only Q1 state, and this is Arden's theorem, by which we convert DFA to regular expression. Now, we have to move to the topic which is regular expression to DFA conversion. First, I will explain conversion
जी हो
of
गया.
regular expression to DFA. First rule is union. First rule is union, which R is equal to R1 plus R2, where R1 and R2 are the two regular expressions. We state that union of two regular expression is also a regular expression, which is shown in the diagram, where E stands for epsilon. Concatenation states that R is equals to concatenation of R1 and R2, where R1 and R2 are the two regular expressions which is shown in the figure below. Third rule is which is R is equals to R1 star, in which R1 star is a self loop on any state with value epsilon, which is shown in the figure. Now, let with the help of an example. Now, there are example which are regular expression given below: 0 plus 1 star, 0 0 plus 1 1, 0 plus 1 star. Now, in figure A, it is shown that Q0 and QF are the two states, where Q0 is the initial state and QF is the final state. Now, in this figure B, we split the regular expression into four states: Q0, Q1, Q2, and Qf. Now on Q0 to Q1, there are self loop of 0 plus 1 string. From Q1 to Q2, there is 0 0 plus 1 1 string. And from Q2 to QF, again there is a self loop of 0 plus 1 star. Now applying the rules of conversion RE to DFA conversion. Now, applying the rules of conversions, we are obtaining figure D. In this figure, Q1 to Q7 is 0, Q1 to Q7 is 0, Q7 to Q2 is 0, Q1 to Q8 is 1, and Q8 to Q2 is 1. This is the self loop of 0 plus 1 star. And by this, applying all the rules, we obtain the final expression D, which is the final DFA of regular expression given in the example. And this is all about conversion of regular expression to DFA. Thank you. Oh,